Hey guys, so in today's lecture, we are going to discuss BER and soot reduction. So, what is BER? So, BER is boiler evaporation ratio. So, BER is boiler evaporation ratio. So, boiler evaporation ratio is defined as the ratio of kilogram of steam generated to the per kilogram of fuel consumed. So it is also known as steam to fuel ratio. So how much steam is produced and how much fuel is consumed. So typically BER for coal fired boiler is 6, for oil fired boiler it is 13. So this is BER. So this is very important definition. Then next is soot. So soot and slag are the mixture of solid carbon, ash and molten ash that sticks to the fire side of the tube and prevents the heat transfer. So slag is also cause corrosion. So scale, what is scale? So as we know, scale we call char is a hard coating of layer of chemicals and materials on the internal surfaces of the boiler. So the on the internal surfaces there is scale formation are happened. So this scale migrates the heat transfer, uh, mitigates the heat transfer and may lead to corrosion as well. So scale and soot prevention is the most important task. So we need to remove the soot and prevent the both soot and scale. So what type of soot blowers are used? So there are three types of soot blowers, which are wall blowers, long retractable soot blower, and air heater blower. So what does blower do? So a soot blower maybe we can operate manually or automatically remotely controlled motor. So the soot is removed from the heating surfaces. So from the heating surface it is removed and will be blown out. Will be blown out to the with the help with the flue gases. Where the flue gases are blown out, so it is blown out there. So if the boiler is equipped with dust collector, so it will trap the soot. So if we have installed a dust collector, so it will trap the soot. Otherwise the soot will be ejected outside in the air through the chimney stack. So through this chimney it will be extracted out. So that is the function of a soot blower. Now what are the problems, why we need to remove the soot? So there are two main problems. First is reduced efficiency. So soot deposited on the heating surface of a boiler, it will act as an insulator, means it will not help in transferring the heat, and it will act as an insulator. It will act as a coating layer. So this results in less heat transfer to the water to raise the steam, and more heat is wasted up the chimney, and this leads to higher fuel consumption. So as we know that we extract the heat from the flue gases, so we need to extract the heat the heat transfer is required, so that heat is supplied to the incoming water. So less heat is transferred, so we need to heat the water more. So our goal is to extract maximum heat. So that is the reason the efficiency can be reduced due to soot. Then soot fires. So a soot fire is localized hotspot which can damage the boiler. That is, these hotspots may reach the temperature that can weaken the tubes material, that is whatever the material of the tube that is of made, that is of metal. So due to this soot, the temperature is very much high, so it will create a hot spot. So uh, it will reduce the material capacity to hold that much temperature, so it will reduce its quality. So soot blowers are reduced to risk of soot fires and the resulting damage. So this will increase the damages. So these are the reason why what the soot is causing. So next is how we can reduce it. So how we can reduce this soot? So soot deposition reduction we can do in four ways. So we can do in four ways. First is use of preheated feed water during startup. So to avoid the condensation of some of the gas constituents, preheated feed water should be used during startup as well as during low load operation. So we need to preheat the water. Then next, boiler water circulation system and its control system are functioning properly. So we need to check the circulation of water in boiler, so it is happening properly or not. Then third is, then next is uh, once the engine is stopped, suppose engine is stopped, the boiler water circulating pump should be kept running till the boiler temperature reaches below 120 degrees Celsius. So the pump should not be stopped immediately because the heat may be there. So because wet oily soot may catch fire at temperature above this. So if suppose by mistake you stop the pump also, so the temperature will rise and it will catch fire. The next is fourth. So we strictly observe that heavy smoke is not coming out of boiler during acceleration or constant. So this shows that upcoming difficulties. So boilers should be checked and cleaned if required. So if heavy smoke is not coming during acceleration, if the power is accelerated, then more smoke should be come down. So that you need to check. So these are the four steps by which we can reduce the soot deposition. So here now we have discussed soot problems caused by soot, how we can reduce the soot deposition, and various function of soot blowers and which are the soot blowers used. So this was everything about soot. Now next is performance evaluation. So the performance of the boiler is to be measured, as you should know that everything which we are going to discuss will be about the boiler only. So all the topics we are discussing about the boilers. So we are now performance evaluation. So of whose performance evaluation? So of the boiler only we are considering. So the performance evaluation of the boiler is measured in two parameters. So first is efficiency and second is evaporation ratio. So efficiency is defined as the ratio of As we know that efficiency is called output upon input. Okay, but what is the output? So output is in the form of steam. And what is the input? So input is in the form of fuel. So that is efficiency. Now what is evaporation ratio? So this is also another parameter to measure the performance. So it is quantity of the steam generated to the quantity of fuel consumed. So these two parameters will be used. So as this we have discussed earlier, now only at the starting of the lecture, that is BER, boiling evaporation ratio. So efficiency and BER. Now generally there are two methods to measure the boiler efficiency. So we will use generally two methods. So first is boiler efficiency measurement methods. So first is direct method. So in this method, ratio of heat output upon input is directly used to calculate the efficiency. As we know that heat input is in the form of fuel consumed in the boiler, and heat output is in terms of steam generated. So we can write this as efficiency is equal to heat output upon heat input. Now what is the output? So in the terms of enthalpy, we can write that m dot of steam, that is mass flow rate of steam, S, into enthalpy of steam minus enthalpy of feed water. So that is the output of the this boiler. Now what is the input? So input is mass flow rate of fuel consumed into gross calorific values of the fuel, CV, calorific value of the fuel. So this is the efficiency of, so this is the formula of efficiency of the boiler. So this is the direct method. So here we need various quantities, uh, that is MF, MS, CV. All this quantity is required. So this all the quantities we need to find before finding the efficiency. Now this method has some drawbacks. So this method does not consider various kinds of losses which are responsible for lower efficiency. So this method, you will get the, we can get that what is the efficiency, but which factors due to which the efficiency is reduced, we cannot find it. So it does not also give the clue to the operator as why the efficiency of the system is lower. So we don't know why the efficiency is lower. So we have invented a new method. So a new method is invented, that is indirect method. So in order to overcome the drawbacks of direct method, this was used for calculating the efficiency of the boiler. So the efficiency by the both the methods should be almost same, but just the parameters involved in reducing the efficiency can be calculated. So in indirect method, all the losses occurring in the boilers are considered. So the accurate boiler efficiency is calculated. So all the losses are summed up and deducted from 100%. That is 100% efficiency. That is maximum efficiency. So what are all the losses? So we will discuss one by one. So as you can see that the losses are losses L1 that is loss due to dry flue gases. Now there are total 10 steps to calculate the uh, efficiency by indirect method. So uh, the fuel gas analysis is required to be done in the form of ultimate analysis. So first of all, theoretical air fuel ratio. So losses due to dry flue gases. So for dry flue gases, what is the formula for loss due to dry flue gases? So losses due to dry flue gases will be m mass of fuel into Cp into Tf minus Ta upon Cv of the fuel. So Cp is specific heat, Tf and Ta are temperature of flue gases and air. So it is the ratio of the loss due to dry flue gases upon calorific value of the fuel. So what is the Cv of the fuel and how much energy is lost? So this is calculated in L1. Then L2 is loss due to hydrogen in fuel. Then now for hydrogen, the formula is, just wait a second. For hydrogen, the formula is 9H2 into 584 plus Cp into Tf minus Ta upon Cv of the fuel. So with the help of this formula, we can find losses due to hydrogen. So H2 is in kg of hydrogen present in fuel of 1 kg of bases. So that is 9H2 into 584. Then similarly, if we want to find the loss due to moisture in the fuel, then here instead of 9H2 we will use M. So what is M? M is the kg of moisture in the fuel. Then we need to find the moisture in the air. So if we want to find the moisture in the air, then we will just multiply uh, for finding moisture in the air will be L4 will be AAS. What is AAS? So it is ambient air into humidity factor into Cp into Tf minus Ta. That is temperature of fuel minus temperature of air. So divided by calorific value of fuel Cv. So this is the loss due to moisture in the air. Similarly, if we want to find the loss due to CO, carbon monoxide, so it will be L5 is equal to 5744 5744 into percentage of CO into C divided by percentage of CO plus percentage of CO2 into calorific value of the fuel. So this is the loss due to CO. So CO is generally given in ppm, parts per million, so you can convert in ppm. Then next loss is loss due to surface radiation and convection. So that is generally calculated for boiler is 1.5 to 2.5%. If fire tube boiler is used, if water tube boiler is used, then 2 to 3%, and for power station boiler 0.4 to 1%. So that is L6 due to convection and radiation. Then last, unburnt fly ash and bottom ash. So L7 will and L8 will be total ash collected per kg of fuel burn, total ash collected per kg of fuel burn into CV of fly ash upon into CV of bottom ash divided by CV of fuel divided by CV of fuel. So this is the formula for losses due to unburnt in fly ash and bottom ash. So all these losses is subtracted from 100, so we will get the efficiency. So this kind of example is asked in exam uh, to find various losses and to find efficiency indirectly, and also compare it with directly formula. So that kind of example is asked in exam also. So this all formulas you need to remember so that you can solve this in exam. So we will see one example in the next lecture. So thank you very much.